welcome to another episode of the Day Zero podcast, another bounty episode, that is. I'm Spectre, with me is Z. Today we have two AWS focused topics on their relational database service and VPN client, as well as a mix of a few other topics that we found a bit interesting. As always, the Spot the Vuln solution will be covered on our binary episode tomorrow. And before we get started, also thank you, Leonie Fortnite, for the bit donation. All right, so we'll lead off with some Git bugs that were detailed on the GitHub blog here. It's worth noting these issues don't affect GitHub specifically, but affect the Git local client. So they recommend people update their local client. Um, Vulnerabilities aren't super complex here. There's two of them. First vuln is the fact that when you use Git outside of a repository, Git will traverse up the current directory to look for like Git configuration information, and it will traverse past ownership boundaries. So on a shared system, it's possible for a malicious user to write a bad config or a malicious config at some higher level directory, like directly in the root of the C drive or something. And because there's some config variables like core.fsmonitor that can do dangerous actions like invoke executables, they can be used to gain code execution in the context of the user who would have run the git command outside of a repo. Obviously, pretty unlikely attack scenario, but it's still a valid issue. And that was fixed by just making it so that Git will respect the directory ownership now. So whenever it reaches a directory that isn't owned by the user, it'll just it won't traverse any farther than that. Um,
Yeah, I agree with you that it is one of those things where the likelihood of having this tacked is pretty low because you are requiring one just like user interaction or something like that where somebody's trying to execute Git inside of a repository or inside of a non-repository directory. It happens from time to time, so like it can happen. And then you also need some that's able to plant this .get folder somewhere higher in the chain, so like your C drive. I mean, they use the example here of writing right to the C root, and then .get, which I mean, sure, that would catch everything, but who's able to write there? Um, I recall on Windows you've got to be admin to write directly to the C root now, also. So you can't just go and add your own files there, as far as I'm aware. Maybe I'm mistaken about that. I know that wasn't always the case, but I believe it is now on 10 and I think 7. Um, so like your chance of if you already have admin privs, this isn't really gaining you anything. The only place I could really maybe see this happening is like some sort of app inside of like the temporary app directory, and then being able to plant it a little bit higher there where you can do that as the user. So like I can imagine a scenario. I don't find it super likely, but I still thought it was an interesting attack to at least call out here, especially on I like calling out those things for like pen testing where you do end up in some pretty random scenarios that you just might be able to cause this situation. But in general, like it does feel like, an average user probably isn't going to be too likely to get hit here.
Yeah, I mainly just found it cool because it's one of those ninja type scenarios where you wouldn't expect Git to behave like this. So it's one of those hidden behaviors that could be abused in a very specific situation. Not a super practical one, but it is there, and it is kind of a weird behavior that it's good to document.
Yeah, I mean, I don't really fault Git because this .git directory is usually at the top of every repository. Again, it doesn't add that into every folder. So, like, you're left in a scenario, it needs to go find it, and if you're not really thinking about the code, or if you're not really thinking about the permissions in the code, you don't think about crossing that privilege boundary, you're just thinking you're finding the Git repository, and I don't know, I could completely understand somebody not really thinking about, what if we look for this and, like, it's a maliciously planted one, like, I don't know, that's not a thought that's really crossed my mind.
Yeah, same here. So yeah, it was kind of cool to read that attack.
Yeah, definitely
Um,
a lot easier than the last Git one we covered, which was that weird race condition on exporting with the symlinks.
yeah. The second bug was with the Git uninstaller for Windows. Basically, there it would use the default Windows temp directory and the system user for uninstalling, and they would load DLLs from the temp directory. Problem is, the Windows temp directory is world writable, so you just have your classic DLL hijack attack going on there. User could write a malicious DLL in there, get it loaded, and executed the system. Pretty straightforward, but a lot more impactful of an attack than the first one, because this one is a lot more practical to pull off. So, um, yeah, not super complex vulnerabilities coming out here. And like I said, they don't affect GitHub or GitLab or anything. They're specific to the Git local binary, but and it seems to mostly just affect Windows. But still, I mean, good to be aware of them.
Yeah, there's still interesting things. Like, in general, you can find these sorts of issues in other applications too. Like, they are things you can look for. Using the world writable locations for deals, or even the traversing up for a configuration directory isn't all that unheard of. I mean, just thinking about it now, I'd wonder if you could have a similar attack going against, like the IntelliJ products, or JetBrain products, sorry. Where it's looking for the idea folder. I don't know, since you load it, you give it the direct folder to load, I feel like it wouldn't traverse up, but a lot of applications do create that sort of folder and then might need to look for it, so there are other places you could probably find a similar sort of issue.
Yeah, true. All right. So with that said, we'll get into our second topic here, which I'll let Z get into.
Yeah, and this one is, well, as the title says, got AWS Relational Database Service, and they have a vulnerability that leaks the credentials for an internal service. They don't go into the details about what the internal service does. They just happen to be able to read credential files, and they load in, see that's like some internal AWS service. Not sure where they'd go from there, but that in itself is a bit of a claim. So if you're not familiar with RDS, or Relational Database Service, I mean, this is effectively just a managed database service. You can spin it up with whatever supported relational database engine you want. So think like MySQL, SQL Server. They have their own forks like PG or Postgres SQL. I don't know how to say that one. PG SQL and MySQL. So they have a fork of that. Aurora. You can basically run it with whatever, and you get access to the database. You don't get access to the underlying like EC2 instance or whatever it's actually running on. You just get the database. They manage the rest. They'll scale it and everything for you. So fairly locked down, or at least in theory should be locked down. And what the Lightsman team here found, I thought was just a cool little oversight. Just really kind of shows how with security, like as an attacker, you need to get lucky once, but the defenders need to, find absolutely everything, or you'll find your way in. In this case, kind of comes down, they're trying to limit access to the host file system. So of course, they do all of their testing here with a PG SQL setup, and there's usually like some ways to load in host data through that. You're restricted from accessing those. You don't have super user access, so they don't like you just call out and just read whatever files you want using the normal PG SQL. What they do provide, though, are some extensions. And what they found was, uh, obviously, the untrusted extensions that would give you back access to do whatever were not trusted. You weren't allowed to load them. So that include things like, what is like PL, PL Python, PL, like whatever procedural language you want to use. Adding that would give you back file system access, so you're not allowed to do that. But they did find one of these extensions that was allowed was the log FDW, I believe.
Yeah, it was the log FDW foreign data wrapper. Yeah.
Yeah. I was just trying to control F, but I can't type today. But yeah, so they had the log foreign data wrapper, and the idea of that is you can load your log files into PGSQL. And it'll expose it as a table, basically. So you can give it a little bit of information about the file, and it'll load that file up, and you can read the lines of the file, and the data actually being split into columns. Add some nice stuff around that, but effectively you just have this foreign data being loaded in. Of course, Amazon did have some security around that. You couldn't just load arbitrary files, but it was kind of a weak enforcement of that. The way these foreign data sources work is you basically end up defining your handler function and a validator function. Um, these are generally implemented in like a C library or something that gets loaded as part of the extension. But you define these two functions, or just one actually. You just need the handler function. Validator will, when you give it a foreign data source, it'll basically validate the option. So just gives you a chance to run the validator. That's optional, and then the handler actually loads it. What that also means is you can go ahead and just disable the validation function or the validation handler and just say, nope, I don't want to run that. And then the handler just gets it. So in this case, even though Amazon did have some security there to prevent just loading arbitrary files, that was only enforced in this validator. So basically, by running the alter foreign data wrapper log and just telling it like no validator, they were able to bypass the checks that actually enforced or prevented you from loading just arbitrary local files. By turning that off, the actual handler itself didn't do any of these checks. Therefore, they were able to load like Etsy password or anything like that. And so they ended up diving through a few configuration files, ultimately leading them to um, this Grover volume configuration, which led them to the Grover credential JSON file, giving them the secret key and like token for whatever this account is. They were able to load that up and like see that it was some sort of internal AWS thing. Not really a lot of information about going on from there, because obviously at that point, you should be reporting, not keep compromising, which is what they did. And it was patched pretty quickly. They had an initial patch up within like 5 days. And then they also took the time to reach out to all of their clients and fix and helped all of them upgrade for anybody that couldn't be automatically upgraded.
Yeah, I thought it was kind of interesting that you could just switch out the validator like that. Now I'm not like I don't really use Postgres. I haven't really had a need for it. I haven't really done much database stuff in general in the last couple of years, but I just yeah, I thought that was a little interesting that you could just swap out the validator like that. Though to be fair, that's probably just because the validator is expected, like it's not expected to validate against someone who already has um like access to run queries, right? It's to protect the front end that would be using them. So kind of makes sense there, I guess, when you think about it. But yeah, um, I kind of that was something I learned when I read the blog post was that you could
Yeah,
just
I
alter the
was
validator.
I was a little bit surprised in the same way, like that you could just disable it. That's why I referenced at the start. It does feel like one of those things where it's really easy to overlook that fact because it is a bit of an interesting use case. That you do have that level of access, but not also to the host system, which at least when PG-SQL was being developed, like even these sorts of cloud deployments weren't the most common situation. Usually it would just be like, um, maybe multi-users on the database system, not so much this level of access. So could kind of have some historic reasons on that. But as AWS, like they have to be aware of all of these little things that can still be configured.
Yeah, it's kind of the death by a thousand cuts thing when it comes to the cloud because there's so many different entry points and vectors that can be abused. All right, so continuing with AWS, we have a Privesk in AWS VPN coming out of Rhino Security Labs, which involves two vulnerabilities: an arbitrary file write as system and an info leak through UNC path. The first bug is basically very similar to the bug we covered last week in pre-tunnel VPN, um, just like pre-tunnel with the AWS VPN, they wrap around OpenVPN, and they have this configuration file that gets passed to it, which just like pre-tunnel, they validate the check for malicious directives, like the executable directives or the logging directives. But there's a race condition where that file can be written to by anyone. So post validation, but before it's actually used, you can just switch out the configuration, put in some malicious directives, and get some primitives that way. Um, just like with pre-tunnel as well, they do use the script security one flag, so it wasn't quick, immediate code execution with just using the executable based directives. But they could use the same trick that we covered last week, which was using the log directive to get Some attacker controlled contents written to an arbitrary file as system, which I believe last week the way that they abused that was to write a local batch file, which they were able to get executed in the system as well. Um, the info disclosure is also pretty straightforward. This is actually in the validation of the config file itself, and the problem there is when it tries to check the file paths that are supplied to any directives that use it, they try to do this like pre-check to see if the file even exists. Um, and to do that, they simply use a try catch and see if they can open the file, which makes sense. That's kind of a common way of doing it. But the problem is, it's possible for an attacker to pass a UNC path in there, which UNC paths. It's actually been a while. We used to cover issues regarding these quite a bit on the show, but we haven't in a long time. But they're kind of like this weird thing with Windows where you can access networked resources. It's kind of like a necessary evil, I guess, especially when you get to like enterprise setups. But they're very powerful in this regard because when they're opened, um, Windows tries to do that networking and it'll pass the user's net NTLM hash over. So by just passing a UNC path to like a malicious attacker server, they can extract a user's NTLM hash. So yeah, kind of cool to see that come back into the show. Like I said, I don't even remember the last time we covered an issue that regarded UNC path, but
Would have been quite a while ago. I mean, in a
yeah,
large part, it's not that interesting of a vulnerability. You give a UNC path on Windows. If you try and open it, it sends the hash. It does that. I mean, that's just not that interesting of a vulnerability. It is a test case to keep in mind, looking on bounties or whatever. If it is like a Windows server, maybe keep that in mind. But oh no, this one, oh no, in this particular case, it feels like such an ask that you're going to be in the scenario where this really matters, like that somebody's going to go and import a malicious VPN config like this. I mean, it's possible, but then also under the AWS thing, I don't know. I mean, it's worth calling out that it's there, but it does feel like a bit of an ask. And I kind of just want to call it that first one, the arbitrary file write, in part because we just covered it last week. Very similar issue. I mean, it's slightly easier here. But more is just like, this seems to exist in a lot of cases with OpenVPN in general. Anything that's kind of wrapping OpenVPN, which is quite a few services out there. Um, so the fact that we're covering this, in back-to-back weeks is kind of saying like, yeah, maybe take a look at this if you're dealing with OpenVPN, or anybody running OpenVPN as part of their service.
yeah, it seems to be one of those things that's like copy pasted kind of where it's the setup is done basically the exact same way across all applications, or and I won't say all, a lot of applications that wrap around OpenVPN. So yeah, that's a good call out as well. All right, so we'll get into our last topic here, which is from GitHub Security Lab. Bit of a quick one that was a last minute ad, so I'll let Z get into this one real quick.
Yeah, it's it's kind of a silly issue, but also just something I hadn't really considered much before. So the issue here is in this VD editor. Basically seems to be like a rich text editor. And what you're able to do is effectively, if you have a copy of, like, in your clipboard, if you have a copy of some HTML, so not like the raw HTML itself, but trying to copy the actual elements, and you have an editor that supports like pasting in images or something like that. That sort of rich feature support. Um, if you have that and you copy in HTML with like JavaScript in it, or in this case, they're using the image on load to get cross-site scripting. Pasting that into the editor then actually results in, well, XSS on that application. In terms of a practical attack, like, that's a huge ask for user interaction. They've got to copy something that's malicious and then paste it in somewhere in that's vulnerable. Really big ask, but I also thought it was a really interesting attack surface. And they call out this copy paste playground here. I guess I didn't copy it. Also can't seem to select it for some reason right now, but they call it this little playground that lets you put basically your HTML, it'll convert it into your clipboard as the actual HTML elements, uh, which seems like it would be useful for testing for this sort of thing. Um, and basically just makes it possible to play around with this a little bit. So I did at least want to call out that location, but as an issue, like, yeah, this particular one feels like it's a huge ask to actually attack this, but I don't know. I've never really thought about these rich editors and the pasting functionality there of rich content as one of the vulnerability areas, or as like an area to look for. So figured I'd at least give it a shout out here, despite the impractical nature of this particular case.
Yeah, same here. I hadn't really thought of that scenario either, which makes me feel a little bit dumb because I mean it totally makes sense that you would want to check this, but uh, yeah, I guess it just haven't really seen this kind of functionality abused too much in the topics that we cover and the feeds that we look at. So I guess that's partially why. But yeah, um, not too much there really. It's not really a super complex attack, but it is kind of an interesting vector that's not really thought of. So yeah.
Yeah, and that's basically the only reason I want to call it out. I mean, I'll be honest, this week was a little bit slow when it comes to the topics. There weren't a lot of write ups for us to cover this week. But at least a couple sort of interesting scenarios.
Yeah. All right. So, like Z said, we don't really have anything else that to cover for this week, so that's where we'll wrap up the episode. Thank you, everyone who tuned in. VOD will be up on YouTube and Spotify and other platforms tomorrow. Remember to check out our Discord or follow us on Twitter. Links for those are on our site or in the chat. And we'll see you tomorrow. That's in our binary episode at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.